Hello everyone. I'm going to demonstrate the effects of noise or stray capacitance on a simple 2-transistor circuit. This circuit is the lab for week 7. The LED comes on with momentary connection from one of the switches, and it stays on even when the switch is released and remains open. The LED turns off by momentary depression of another switch, which keeps the LED off even when the switch opens. So you can see the LED is on. Now apply voltage here, and the LED is off. This is my high-tech switch, a piece of wire. The difficulty with this circuit is its sensitivity. If I were to go and make a measurement here, or even here, as you can see, the LED wants to come on by itself. This is voltage picked up, probably coming from my body as I serve as an antenna. I'll turn the LED off and show this again. Just there, just touching a test lead is even enough of an antenna to turn the LED on. I will turn it off. And now I will remove power. I'm going to remove one end of the resistor. This is the 100k ohm resistor, at least for my version of the lab. That value will vary depending on which version you have. And now the transistor Q2 is essentially isolated from the circuit. The only way the LED will come on now is by applying a steady voltage at the 2.2k ohm resistor. So as soon as I release the switch, it's going to turn off. So this point is not sensitive, so the base of Q1 is not the problem. It is the base of Q2 that is very sensitive. In fact, if I just touch this lead, this resistor lead that's open in space but leads to the base of Q2, you can see the LED turns on and off with nothing more than a very low voltage emanating from my body. So how do we take care of that? Well, first I'm going to remove power again, reconnect the resistor, back goes to the collector of Q1, and then it travels to the base of Q2. And get that back in there. Apply power again. The LED wants to come on just at power up. I can turn it off, turn it on, turn it off to assure everything is working. But here is what I can do is take a 10k ohm resistor, for example. I sort of chose this randomly, but with some thought. And I will connect this resistor to where it becomes a grounding circuit, or a grounding path, for the base of Q1. And now I will turn the LED off. So now when I touch this point, the LED is not nearly as sensitive. Now again, it is not the base of Q1 that is the culprit. However, what I believe is happening without the addition of this 10k ohm resistor is that voltage from my body is traveling through the 2.2k ohm resistor at point A in the circuit, and it is capacitively coupled through Q1 to its collector and then ultimately to the base of Q2 through capacitive coupling provided by the PN junction between the base and collector of Q1. At least that is my theory on this. But at least you can see the circuit is not sensitive with the 10k ohm resistor in place. When I remove the 10k ohm resistor, the circuit becomes very sensitive, and now when I touch it with a test lead, the light will more than likely, as it's shown there, as it did there, turn on. But at least it continues to work as normal, but is sensitive to stray voltages. Thank you for your time.